Okay, there are actually two laws we're going to talk about. 6.5 deals with what's called the law of sines. 6.6 deals with the law of cosines. And you can't really use them interchangeably. You have to use one or the other, and it has to fit the situation. So I want you to draw 4 triangles. Try to make them about the same. Ooh, check this out. I'm just going to duplicate. Oh, this is awesome. Mine are exactly the same. Can you guys claim that all 4 of your triangles are exactly the same? I don't think so. Pay no attention to that. Yep, you need 4 triangles. Because how the triangles are labeled, or I guess what information you've been given regarding the triangles, determines whether you're going to use law of sines or law of cosines. You got to think way back to your geometry class, which for most of you was, what, 3 years ago now? Does side, 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 or side, angle, side, or angle, side, angle sound familiar? Yes. That's going to determine which law you use. Those are laws of congruence, you're right, but those cases are going to determine whether you use law of sines or whether you use law of cosines. So let's say that you have an angle here, alpha, an angle beta here, and let's say that you know side A. That would be angle, side, angle, right? Mm-hmm. Angle, side, angle? Yeah. Let's say you knew angle here, alpha, angle beta there, and let's say that you knew a side A right there. What would you call that case? That's angle, angle, side. No, we're not gonna, not yet. That's 2 chapters from now. What if we knew side A here, side B, and angle alpha? What case would you call that? This one is angle. Which one is it? Side, angle, side. This one's called side, angle, side. SAS. And then let's say we know side A, we know side B, and we know side C. That's side, side, side. So these 2 here, whoa, where'd you go? There you are. These first 2, if it's angle, side, angle, or angle, angle, side, these are going to be solved using the law of sines. If it's side, angle, side, or side, 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 those have to be solved using the law of cosines, which we'll talk about next time. That's the lesson for Thursday. Now we are missing one. Do you remember in geometry, because I knew you were probably thinking it because you were stupid, immature geometry kids, what's missing obviously on there? And you probably asked your teacher, where's angle, side, side, man? Didn't you say it just like that? No. That's how you sound to us geometry teachers when students say that. The reason that doesn't work in right triangles is because angle, side, side doesn't determine a unique triangle. There could be lots of different triangles with the same measurements, angle, side, side. However, there is such a case not involving right triangles. So draw one more triangle. Do angle alpha here, side A and side B. This is actually called side, side, angle. It's called side, side, angle. This is what's referred to as the ambiguous case of law of sine. So you can still use law of sines with side-side angle, but it's an ambiguous case, and I'll talk about what that means here in just a second. So here's law of sines. Draw one of those triangles you've been drawing. Label the vertices now. Instead of labeling angles inside the triangle, label the vertices as capital A here. Label this one capital B. And label that one capital C. And then starting from vertex A, have an altitude drop straight down perpendicular to the base of that triangle. And let's call this H. What does H equal to? Well, let's label this further. If this is, I think we talked about this last time. If this is angle B, then where's side B? So this is little b over here. What else do we know? If this is angle C or vertex C, then that means this is little c and this is little a down there. So H, let me give you a hint, and I want you guys to answer this. What does H equal in terms of angle C and side B? Think about that. What does H equal in terms of angle C and side B? Let me give you one more hint, and then I want you to see how far you can get. Think about, instead of the original triangle that I drew, think now about just this. Why just that triangle? It's a right triangle. So take a second here. See if you can come up with what H equals in terms of angle C and side B. Don't yell it out, just write it down. So using, well, you can't see it. Using this triangle that I've blacked out here, if we just started with not H equals, what about sine of C? What is the sine of C equal to? What's the definition of sine? So if we're just thinking about this right triangle, what's opposite of angle C here? H over B. Sine of C is equal to H over B. So now what is H equal to? H is equal to B times the sine of C. Can we do a similar thing using this right triangle here? What is H equal to in terms of that other right triangle on the left side?
Sine of B is H over C.
Sine of B is equal to H over C. So now what is H equal to? C times the sine of B. What we're doing here is deriving the law of sine, so you can see where it came from. If H is equal to B sine of C, but H is also equal to C sine of B, what the heck does that mean?
C sine of B is equal to C sine.
Yeah. If both of these equal h, doesn't that mean they equal each other? Because h is h. It's the same length. So if it equals one thing here and it equals another thing here, that means these two things equal each other. So we can claim that b times the sine of c is equal to c times the sine of b we're going into the proof of the law of sines. We clear on where we're going with this so far? Give you a minute to catch up. Now, we're missing one final step. Let me actually write one part of the law of sines. Here's where we need to go with this.
Divide the sines from each side.
This is where we need to end up right here. The c over sine of c is equal to b over sine of b. This right here is the law of sines, or at least a part of it. There's one piece I left off on purpose, but we need to go from here to here.
Divide by the sine.
What is that? What do you mean? Say that again.
Like divide each side by the sine of c and the sine of b in most of the places.
Divide this whole side. Say that one more time.
By the sine of b.
Sine b and
Sine c.
sine c. There you go. If we divide that side by sine b side c, and divide this side by sine b sine c, as long as we divide both sides by the same thing, we can do that. We can do whatever we want, really, but as long as it's the same. Here the sines b cancel. Here the sine c cancels. So that leads us to this. Using a similar proof, we don't really have time for it, but using a similar proof, we would also be able to add another piece to this. Little a over sine of a. This right here is what's called the law of sines. C over sine c is equal to b over sine b, which is also equal to a over sine a. Now, depending on whether or not you're trying to find a side or an angle, you can invert all of these fractions. Sometimes it's easier to think about the reciprocal of these. So, similarly, this is also true. Sine of c over c is equal to sine of b over b, which is equal to sine of a over a. That's also a variation of the law of sines. So here's an example. Let's try trying. Didn't want that. Better again. Label the vertices A, B, and C. Angle A is 20 degrees. Angle C is 25 degrees. And side C, little c, lowercase c, is 80.4. Solve for little a. Now, it's going to be obvious on the homework from section 6.5 that you're going to be using law of sines because the title of the lesson is law of sines. But on a test, you're going to have to make the decision, is this where we use law of sines or is this where we make law of cosines? Because I'm not going to tell you. You're going to have to decide. And if you choose wrong, the answer is not going to make sense. You might not be able to find an answer. So let's just go from the understanding that we're not sure that we're going to use law of sines. How do we know that we're going to be using law of sines? Go ahead. Which case do we have? Is that what you're talking about? So we know angle A right here is 20. We know angle C is 25. And where's side C? Between A and B, so this is 80.4. So what case is this? This is side angle angle or angle angle. This is angle angle side. What do we say with angle angle side? Angle side is law of sine. And here's one other thing that's really easier to tell with law of sines. If you have an angle and the side across from it, if you have an angle and the side across from it, you're going to use law of sine. That makes sense? We have angle C and we know the side across from it, side C. That's always an indication of using law of sines. Now here's the thing, you guys. Listen carefully. You never ever use all three pieces of the law of sines. Because an equation doesn't have two equal signs. It doesn't make sense. You're going to have to choose two of these pieces, and you got to choose the two pieces that use the information that you have and that you're trying to find. Does that make sense? You're either going to use these two pieces here, or you're going to use these two pieces here, or you're going to use these two here, but never all three at the same time. You got to choose the correct two. So with the information that we're given and what we're looking for, what two pieces would you suggest we use? These two right here. Because we're looking for little a. Well, I would actually use this version. Whatever you're looking for, it's easiest if you put that variable on the top of a fraction and not the bottom. So I'm going to use these two versions of it. We're going to use little c over sine c is equal to little a over sine A. So fill in what you know and then solve for what you don't know. We know that little c is 80.4 divided by the sine of 25. That's equal to A, the unknown side, over the sine of 20. We only use those two pieces to form an equation because we can only have one equal sign. Yeah. These are pretty easy to solve. Once you've set it up, they're pretty easy to solve. Multiply by the sine of 20 on both sides. So A is equal to the sine of 20 times 80.4 divided by the sine of 25. And you got to be careful how you type this into a calculator, especially if your calculator automatically opens up a parenthesis for you. Some do. So sine, see how mine automatically opens a parenthesis. If I type in sine of 20, but then I don't close it and I start multiplying by 80.4, do you see what the mistake's going to be here? So you've got to make sure to close that parenthesis. Then multiply by 80.4. I'm going to hit enter here. Then divide that by the sine of 25. And I get 65.1. Now this didn't include a unit of measure like feet or inches or yards, but if it did include a unit of measure, you got to make sure that you put that in. So side A here is 65.1. Let's try another. Part B, same example. Actually, let me change direction. Solve. What does that mean? I know. Find all the angles and all the sides. There you go. Solve the triangle.
Earlier on, I thought solve plus HE, like plus Hamiltonian triangle or whatever. I was reading this weird. I was like,
You were reading that weird.
yeah.
Okay. Angle A is 50 degrees. Angle B is 68 degrees. Little c is 230. Now, this one does say specifically use law of you're right, sorry, that's not a degree symbol. The directions on this problem would specifically say to use law of sines, but there's a problem here. Now, you don't have to draw a triangle, nor do you have to really see a triangle, but for some students it helps to visualize. So just draw a random triangle and label the vertices however you want. A, B, C. But then once you label the vertices, you got to make sure to put the correct measurements in there. If I'm calling this vertex A, then that has to be 50 degrees. This has got to be 68 degrees. Side C over here so what case is this? This is angle, side, angle. You're right, angle, side, angle.
Can you just find like without using
Yeah, there's two things I wanted to talk about here. First of all, does angle, side, angle mean that we can use law of sines? Let's check it. Angle, side, angle. Problem is, though, to use law of sines, we have to know an angle and we have to know a side across from that angle. We have to know a side and an angle across from it. All triangles, the measures of all the angles of a triangle, the sum is 180 degrees. Before we can even use law of sines, we're going to have to figure out what angle C is here. Because the only side we know is side C. We have to know the angle across from it. So if we add 50 plus 68, that's 118. If we subtract that from 180, we get 62. So that angle is 62 degrees. So angle C is 62 degrees. So now we know all the angles. Now we can't solve for two sides simultaneously. We have to solve for one. We have to do law of sines again to solve for the other one. The reason we can't solve for two sides simultaneously is that's one equation with two unknowns. We can only have one equation with one unknown. So we've got to choose one. Which one do you want to solve for first, A or B? We're going to go in alphabetical order. Okay. So we're going to do little a over sine of capital A, which is 50 degrees. Now we got to choose the other side of the equation. And this one, we only have one choice. What does the other side have to be? It has to be little c. If we do little b, we don't know little b, so this would give us one equation with two unknowns. But we know little c. That's 230 over the sine of angle C, which we now know is 62 degrees. How do we solve this? Multiply by the sine of 50. So little a is equal to 230 times the sine of 50 all over the sine of 62. What'd you get? 199.5. Alrighty. That's rounded, right? Okay. Now we've got to solve for b. So little b over sine of angle b, which is 68. Now, you can make a choice here. Do we have to use little c over sine c anymore? And the answer is no, but here's the thing. Are you listening carefully? Accuracy is important.
If we choose to use 199.5 over the sine of a, is our answer going to be as accurate as it could be? Why not?
199.5.
We rounded that. So you can use it, but your answer might be slightly off, which, I mean, I'll still give you credit for. I'm not going to dock you points, but in technical situations or mechanical engineering situations where accuracy is important, you're going to want to be as accurate as you can. So I'm going to choose to use C again, because that's not rounded. So 230 over sine of angle C, which is 62. Solve this one the same way. Multiply by the sine of 68. $241.5, okay. Something to consider. This is a theorem that I know you learned in geometry, but I'm sure that some of you, or maybe all of you, have forgotten. But in comparison to the angles of a triangle and the size of a triangle, the side across from the largest angle is the largest side of a triangle. So does our triangle make sense? 68 is the largest angle, so the side across from it ought to be the largest side. Is that true? And the smallest angle, the side across from it ought to be the smallest side, which is the case there. So that seems to make sense. Let's talk about that ambiguous case. Ambiguous case of law of sines. This happens when you're doing side angle. Side angle, David. The reason this has its own special situation is if we're trying to find angles, all we know, if we're given a side and an angle, all we're given is one angle. So how do we find another angle? Can we just subtract it from 180? Like we did on the other one? In order to find another angle in this triangle, what are we going to have to use? The law of sines, right? But isn't capital A or capital B or capital C, those are all angles. Aren't those inside of a sine function in the law of sines? So how do we get those to not be inside of a sine function?
we're going to have to use inverse sine. And here's where the ambiguity comes in. Okay, you listening carefully? When you take the inverse
Sine,
When you take the inverse sine, we're no longer bound by those domain restrictions. Are you listening carefully? When we're taking the inverse sine to solve an equation, I need you to listen carefully to this. Okay?
these domain restrictions that we talked about in the quiz, they only apply when you're evaluating an expression. Okay?
Do you understand the difference between an expression and an equation?
On the quiz, this is what the problem was. Is that an expression or an equation? That's an expression. If you're evaluating an expression, then you are bounded by the domain restrictions that we set in 6.4. Does that make sense? If you're using inverse trigonometry to solve an equation, you're not bound by domain restrictions. Okay? What's the significance of that? Well, if I had an equation sine of x is equal to 1/2, that's no longer an expression. What is that? That's an equation. How do you solve that equation? Use inverse sine. And this is why this is called the ambiguous case. What is the inverse sine of 1/2? If you think about your special triangle, 1, 2, square root of 3 right here is 30 degrees, there's 60 degrees. What angle would give you a sine of 1/2? 30. But isn't there another angle
that would also be positive with sine? What other angle would be positive with sine that would give you 1/2? 150. So which angle is it? Is it 30 or is it 150? It's both. That's why this is called the ambiguous case. Which one is it? Is it 30 or is it 150? Is it both? Maybe it's none of them. Do you understand what I'm talking about here? Why are we not bound by the domain restrictions for that problem? It was an equation. It wasn't an expression. That's why this is called the ambiguous case, because when we're solving for angles, we're solving an equation of sorts, so we're no longer bound by those domain restrictions between 0 and pi or negative pi halves to pi halves. So, I'll talk about that, because sometimes it is both answers, sometimes it's only one of the answers, sometimes it's none of the answers. You have to decide. It's a fun decision to make. So here's an ambiguous case. Example 2, I think. Example 2. So we have angle A is equal to 45 degrees. Little a, oh, they're getting mean on you guys, is 7 squared to 2. And little b is 7.
This is hard.
Solve
It's the right triangle.
for angle B, or capital B. Now, because we're not sure what type of triangle this is, just draw some random triangle, label the vertices however you choose. But once you label them, you've got to make sure that now you mark them correctly. Angle A here has to be 45 degrees. Little a across from it is 7 squared to 2. Little b down here is 7. Now, what case is this? Side, 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 angle, side. Angle, side, angle. Oh, be careful.
Side, side.
It's side, side, angle. This is side, side, angle. So this still does work with the law of sines, but this is the ambiguous case. So now we're solving for angle B. So I'm going to use this version of the law of sines. Sine of B over little b. What should the other side be over here on the right? The ones that involve a. Sine of a over little a. So fill in what you know. Sine of b over little b, 7, equals sine of a over little a. Now how do we solve for b? There's actually two things we need to do here. To multiply by 7 on both sides. So sine of b is equal to 7 times the sine of 45 over 7 squared to 2. Now we are going to have to take inverse sine, but before you do, I would check to see what the value of this is. So I'm going to turn on my calculator. Let me type in 7 sine 45 and then divide that by 7 squared to 2 just to see what that equals. And it equals 1. Why would I want to check to see what that equals? Let's say, for example, this had turned out to be, I don't know, 2.3 or 5.2. It equals 1, but let's say hypothetically this was like 1.2 or 5 or 20. What would the problem with that be? What would the next step be in this situation? How would we solve for b right here? You have to take the inverse sine. So what does it matter what this equals? We can just take the inverse sine of it, right? Well, let's say hypothetically this was 2.3, and then we try to take the inverse sine of 2.3. Whoops. What does that mean? You can only take the inverse sine of values between -1 and 1. It's the range that we're not restricted by. We're still restricted by the domain, but the range could be anything. We can get answers in any quadrant. So the domain still holds. We can only take the inverse sine of values between -1 and 1. So going back to the original problem, are we okay here to take the inverse sine of what this equals? Can we take the inverse sine of 1? Yeah. So the sine of b is equal to 1. Now we take the inverse sine, so capital B is equal to the inverse sine of 1. That you can do on a calculator. Inverse sine of 1 is equal to 90 degrees. That means angle B is a 90-degree angle. And there's no solution. That's what I was trying to get at earlier. With the law of sines, the ambiguous case, you have 3 instances of answers. Either it's no solution, or you have one answer, which means one triangle, or you have 2 triangles. Okay? This is a case sine B equals 90, or rather angle B equals 90. We get one answer here. This is kind of a dumb problem.
I got 1/2 when I did all the math there.
Inverse sine.
The
Inverse sine of 1.
of 1/2.
You type in the inverse sine of 1.
7 sine of 45 divided by 7 squared root of 2 is 1/2, not 1.
7. Oh, I gotta check my mode. I'm in degree mode. 7 sine 45. And then divide that by 7. Uh-oh, I think I know what I forgot to do. I didn't put it in parentheses. 7 root 2. That changes things. See, it wasn't the calculator was wrong. I didn't type it in the right way. Do you see what the difference here was? What did I forget to do? Why did the parentheses matter, by the way? It's dividing, and then I was multiplying. And all order of operations, dividing and multiply come in the same order, so to speak. So if you want to divide by an entire product, you have to put that product in parentheses. I failed to do so. All right, we got to go back and remedy this. So where's my mistake? Where are you? Sine of B, right here. Sine of B is not equal to 1. What did the calculator say was equal to? 0.5. That's why that answer was so strange. 90 degrees. All right, what's the inverse sine of 1/2? So let's type in inverse sine of 0.5. That's 30 degrees. Now we got to think, what other angle would also produce a sine of 1/2? Or what other angle would produce a sine that equals 1/2? And it's 150. So, or 150. Now we got to decide, do both of them work? Or does only one of them work? And here's how you decide. What's the other angle given? The other angle is 45 degrees. We already knew that angle A was equal to 45 degrees. So if we're claiming that both of these angles work, what's the problem with saying that 150 and 4... Whoa. Hello. Hold on there. I got to get rid of that. What's the problem with claiming that both of those angles work? It's greater than 180. Okay, so we can't have a triangle that has a 45-degree angle and a 150-degree angle, because that would be larger than 180 already with just 2 angles. So we don't have to consider the 150 degrees. Okay? The only angle that works here is 30 degrees. We know that for sure angle B is 30 degrees and only 30 degrees. This is one of those cases where you get one answer. Okay? So that's equal to angle B. Let's take a look at one that may have 2. Here's another example, 3. We have angle 8 is 43.1 degrees. Little a is 186.2. And little b is equal to 248.6. Same directions here. Solve for capital B. We better hustle this thing up. So we're going to use this same formula of the law of sine. Sine of b over little b, 248.6, equals the sine of 43.1 over little a, 186.2. Multiply both sides by 248.6. So that gives us the equation sine of b equals 248.6 sine of 43.1.
Does it matter if the angle of the side is not?
It doesn't. No. Just usually whatever variable you're solving for. When you're dealing with proportions like this, it's easier to have that variable on top. But it's up to you. Again, I would check to see what the right side equals, because if this is something that's larger than 1, or it could be less than negative 1, this would be a no solution case because you can't take the inverse sine of a value greater than 1 or less than negative 1. So I'm going to see 248.6 times the sine 43.1 divide by 186.2. And that's 0.91225. What does that mean? Should we proceed or do we have to stop? It's less than 1, so we're good. We can take the inverse sine of it. So angle B is going to be the inverse sine of this value. Now, rather than rounding, and again, this depends on what kind of calculator you're using, but take a look at my screen right here. I'm going to type in inverse sine, and rather than rounding this to 0.91, I'm going to use this whole entire expression. You don't have to type it in by hand. Most calculators have an answer where you can just do this A and S, and it types in the answer above it. So most of your calculators should have that. I'm going to take the inverse sine of that.
Where is it?
On mine, it was right above the negative sign. So angle B, according to this, is 65.8. But now we have to consider the angle in the second quadrant, whose reference angle is 65.8. How do we find that?
Subtract that your angle measure from 180.
Exactly. So I'm going to take 180 and subtract this new angle measure, 65.8. And that's 114.2. Or 114.2 degrees. Both of these are considered possibilities because if you took the sine of either one of those, you'd get 0.91. Now, do they both work? We have to consider the angle that's given. The angle that was given was, what, 40-something? 43.1. Angle A is 43.1 degrees. So what you have to ask is 114 too big? If you took 114.2 and added 43.1, are you above 180? You still have a little bit left over for a third angle. So the answer to this one is angle B could be both of those. There's two such triangles that would match the situation. That's the ambiguous case. Sometimes you get no solution for these. Yep.